Hello and welcome to this webinar. Today we're going to be looking at the topic of making smarter decisions, how you can apply intelligence to your Z applications with digital decisioning. We're going to try and explain a bit about what we mean by digital decisioning, the components that are involved in making a digital decision, and then hopefully give some examples about how we might want to use this in the real world. Today I'm joined by my colleague Maggie Lin from the IBM Watson Machine Learning team, and between us we'll try and describe the pieces that take this up and how you can use them. So I would say this is live, so anything can happen, but it is live unless you're watching the recording. So if you want to ask questions, we'd love to have them. There is a question box at the bottom of the screen, I believe. If you're watching this, please feel free to add questions in there, and we will try and get to those and leave some time for those at the end. So what's the background to this? Why are we talking about this? Well, I think one of the things that the pandemic has definitely heightened is the need for businesses to modernize. A lot of the channels that have been available to us in the past through people coming into branches or meeting with us face to face, one of the things the pandemic has done is taken that away for long periods of time. So the requirement for people to be able to effectively self-serve and actually have things online, to be able to use apps on their phone to access our services, has become more and more important over these last couple of years. And a recent survey that Forrester did showed that 92% of organizations have started or are in the process of an application modernization project. What platform that is and what they're doing are very different, where they're from the initial steps right through to finally seeing returns on it. But I think for most of us, when we think about the term of modernization, particularly in the sense of Z applications, which is kind of like our framework for our discussions today, very often the first thing that comes to mind is rewriting and replatforming. I think what was interesting is in the same survey, 58% said the kind of modernization they were looking at doing was modernization in place. And there can be a lot of advantages to that. Some of the key ones being is that it is far lower cost to just look at the real pains you have with an application and modernize only the bits that need to be modernized and changed. But also it's far lower risk, because if you're only modernizing certain pieces of the applications, you know that the rest of it that's working is going to keep working. And particularly with our Z applications, where we absolutely rely on them for our business, they are the core of the core business applications, then knowing that we are not making a high risk approach can be absolutely key. So what are the kind of things we can do in modernizing an application? There's been a lot of focus recently, obviously, on things like exposing assets as APIs. Obviously, the more we're trying to get access to our applications, to push these out onto mobile devices, onto self-service web portals, these kind of things, having these assets to be able to be accessed from an API, where previously they may only have had direct access from people physically in our locations, in a bank branch or an insurance company's branch. APIs have become more and more important. Also has been the need to have modern DevOps pipelines, the ability to actually make changes, to govern changes, to see what changes we're making across multiple platforms and actually align those together to see who's done what, when and why, and to be able to roll back changes. That kind of thing is very important. But for me, one of the key things is it doesn't matter how good your API is or how good your DevOps pipeline is, if the application itself is not providing the correct, if you like, responses to the customers for the business, then you're not going to have a business for very long. So you can have the best APIs in the world and the best DevOps pipelines, but your applications themselves must be making the right key business decisions. Now, what do I mean by the business decisions? Well, across all industries, there are decisions that we make. Let's take, for example, a bank. Most banks are largely the same when it comes down to it. They have accounts. They may have savings accounts, checkings accounts. They may have loans. They probably have credit cards. These days, they probably also have insurance products and other things they've moved out into. But fundamentally, all banks are largely the same. So what makes one bank successful and one bank not successful? Well, it comes down to the business decisions that they are making. As a bank, for example, are they going to choose to only make a small number of high value loans to very safe customers? Or are they the kind of bank that are going to make a large number of small value loans to much higher risk customers? It's those kind of decisions that are going to determine whether or not your bank is successful or not in a particular market. And it's those kind of decisions that we have to make sure that are in our applications are agile and actually correct to the business policies that the company currently has. So you can imagine in an insurance, it's making sure our risk profile is correct by only offering our insurance products to the people that we want to be able to, that aren't too high risk, or that we aren't outpricing ourselves out of the market. We constantly have to be being agile to our competitors. Are the prices that we are supplying, whether it's in insurance, whether it's interest rates, whether it's in retail, we're not being undercut by our competition, and we're not losing business because we're simply being priced out of the market. Are the decisions we're making auditable? Do we have traceability? There is so much compliance required these days, particularly since, things like the financial crisis that happened many years ago. The things that have been put in place to try and stop that happening again. Can we show that we really are being compliant in an easy way? These days, we hear more and more about cyber attacks. How can we ensure that when we are receiving, a claim for insurance, that that's not a fraudulent claim? Is the detection up to date with the latest things that are coming in to try and attack us, to try and get past our systems? All of these things require us to have really up to date, really agile, but very accurate decisions that need a short path between the person who is defining the policy and the implementation of that policy in our applications. And the three key pillars we need to build this on are, and I've mentioned it several times already, firstly, agility. We need to be able to adapt to the market changes quickly. We want to be able to improve our operational efficiency. Previously, things that we might go in and see our bank manager for and have a conversation with, people aren't wanting to do that anymore. They want a result now. And if they can't get an answer to the loan request in your application or your web app now, they're going to go and find somebody else's who will give them an answer now. So we need to be able to have those instant responses. But in doing that, as I said, we need to make sure that we are compliant with any regulations for whatever our industry happens to be. And we need to be able to do that transparently so that we could show that, yes, we lent this person this amount of money on this date, and yes, they defaulted, but the reason they defaulted was outside of the realms of the compliance rules that were put in place. Therefore, we were okay, and we should have lent that person that money based on the compliance rules. That kind of thing. We need these three pillars to be in place. Now, there are many different ways of making decisions. We could hard code them into applications. We could put them in an email to somebody who has to respond to them back to the application. Or we can use technologies such as business rules to actually code into the application. And we'll talk more about those in a minute. But what we're hearing more and more about, and unless you've been living under a rock for the last 5 or 6 years, you must have heard of the terms of AI and particularly machine learning. So one of the questions we often get is, hang on a minute, I keep being told that I need something like business rules to make my decisions more agile. But I'm also being told that I have to be using things like AI and machine learning or I'm going to be left behind. So which of these technologies should I be looking at if I'm looking for something like an inside out type of modernization to actually modernize an application in place? And what we want to try and talk to you about today is that actually the answer to that question is we believe you should be looking at both, that both operational decisions and business rules and AI and machine learning very, very much have a place in-place modernization. So to begin with, we just want to lay some ground and to make sure everyone's on the same page. So let's quickly look at what business rules are and what they bring you. Then we'll look at what machine learning is and what that brings you, and then kind of would land in a compare and contrast as to how the two of those actually can complement each other in the real world. So very often today in applications, the code that implements that business decision, that business policy, is hard coded into our applications. And it may have been there for many years. It may have been getting more and more complex. And very often, and I know I'm guilty of this sometimes in some of the work I do, if you have to override something, you need a price to be set to something specific, instead of digging your way through the whole code to find the exact line of code where that's set, you might just put an override somewhere where you know it's going to make sure it's set regardless of what else happened. So this logic can just become more and more complex and more difficult to understand. Also, if we want to make a change to these applications, that change is likely to come from the business team. So the business team is going to say, we're being undercut with most of our insurance quotes, for example, aren't being accepted. We need to look at our pricing structure. The first thing they have to do is to look at which application team manages the applications that set the prices. And sometimes, of course, it might be a different application that's doing, say, the overnight renewals as a batch job on ZOS, where our system of record is, compared to a web application that's serving the requests for quotes coming in from things like price comparison sites or directly from our end users. So the first thing they have to do is try and work out where they need to go to make these changes. And generally, IT is always going to be required. And also the big problem we can have here is that if we're making a change to the application, we are going to have to test the whole application. Because I don't know what it's like when you're developing your applications, but certainly for us as a product, if we ever make any change to the application that requires it to be rebuilt, we're going to run a full regression test against that before it goes out of the door, just to make sure we haven't broken anything. So it can be very costly to make these changes. So where we want to move to is to something like an approach where we're isolating out the policy logic that's making those business decisions. Now, what do I mean by that? If we think about an application, we have multiple layers in that application. We have the presentation logic, which these days could be anything from a 3070 interface to a RESTful interface, to a web interface, to anything in between. We have the data layer, where we're actually managing and maintaining our system of record. And that rarely changes. The presentation level rarely changes. If they change, it's a major IT project to change. But the bit that sits in between that we often call the business logic, I like to think of in two pieces. There's sort of the business flow logic and the business policy logic. The business flow logic is, oh, look, I've been requested to see the balance for this particular account number. I will go and get that from the data layer. The business policy logic is the bit that says, I would now like to transfer X amount of money into a particular account. Is that allowed under our current business policies? Is that something we can let this person do? And it's just that piece of logic that we might look at pulling out into something like a business rule system. That's the decision that we're talking about. The key thing that makes one example, going back to earlier, one bank different from another. So in IBM, we have the product to manage this called IBM Operational Decision Manager for ZOS, which we'll look at over the next couple of slides very briefly. But the key things being, the idea is that we can write the rules that make these decisions in a natural language. So we can say things like, if the age of the applicant is less than 18, reject the loan request, and something that the business team themselves can actually get involved in. We can decouple the business rules from the application, and that's key, so that we can make changes to the bits that need to change rapidly on a separate life cycle from the rest of the application. And also, we have that ability to see who's made a decision, when they've made it, and to make sure that the correct sign-off has been given before any of those decisions go into production. And so the key here is making sure we have a full lifecycle management of those business decisions. Now, this is very similar to what you would see at application level, but the key thing here is that we have tools and ability to do this with the correct actors. So if we can bring the business team into this and be involved in this as early as possible, then we have the ability to make sure that we are checking things back before. So we make a change, the business team can look at that change, confirm that change, we can test that change has made the change we want to, and then put it into production without maybe not noticing we've had the wrong rules in place until sort of 6 months down the line. So the first stage of that is we need to capture the rules. Now, I apologize, there's quite a lot on this chart. It's quite busy. But key things to look at, if we look at the top, in natural language, we want to be able to define the rules in a way that we can say, if the driver has completed a driver's ed course and the number of accidents is 0, then we're going to apply a discount. You can see that that language is something that actually might be how the requirement would have previously come to the application developer to code in something like COBOL, PL1, Java, choose your language. We can actually code, if you like, the decision in the same language that the business teams are currently using. And the tooling itself will help guide you through writing these rules. So actually, it's a guided editor. So you don't have to learn this vocabulary, if you like. You'll be guided through what options are available. You can see below that decision tables. Very often, if you think about things like pricing, maybe for, interest rates for an applicant, then there's probably a very tabulature way of doing that based on the income of the applicant and the amount of loan that they want to take out based on that income, or a risk level that's associated with that. And so we can actually manage and maintain the decisions as a table, and maybe even something looking very much like a spreadsheet, which is what the business teams probably use to currently document that. And we have a way with ODM of actually bringing that data into and out of spreadsheets. So the key here is that we're looking for ways of, if you like, modeling the decision in a way that as closely as possible matches the way the business teams would have it. Now, we may not get quite to the point where we can cut and paste directly from the requirements documents, but we should be able to get very close. And we do have a lot of customers who reach the point where instead of having a documentation on the business team side that's passed to IT, actually ODM can be that documentation because it's something that both teams can come together and both teams can understand. But I've talked a lot about different players, different people being involved, the correct actors, and that necessitates a need to be able to actually collaborate with each other. So a key thing is having a point at which you can do that. And one of the key focuses of ODM is having a repository where all these decisions are stored. We can see who's changed what at what time with a timeline. We can version things. We can obviously edit and make changes. But a key thing is when we make changes, we can see what those changes are against previous versions and determine whether or not we're going to allow those changes to go through into production. And obviously, before we do that, we want to be able to test those changes. But the testing can be done in isolation at a business level, just thinking about the decision we're making rather than the full application end to end. So this cycle can be gone around many, many times very, very quickly without even the need to execute anything on ZOS before we get to the point where we believe we have a decision at the point where we can actually deploy it into production. And obviously then we can deploy it into production. But you'll notice this is my third point in talking about. So many rule solutions, all they talk about is the execution. And that's not to say our execution is not good. We have high-speed execution. We have, I'll talk about in a moment, some of our optimized options for ZOS. And we run fast, we run well, and we run auditable. But the key thing is having that full life cycle around knowing what you're executing, who made those changes, and why they made them. And then once something's in production, we want to be able to look back at the decisions we've been making and ensure they are the right decisions. How is our risk profile looking based on the decisions we're making? How many sales are we making? Are sales tailing off for particular products? Are we seeing particular products go through the roof? Is that suspicious? Is there something fraudulent we might want to look into here? So you can see that with ODM, we have that full life cycle ability. And on ZOS particularly, we've not just lifted and shifted the distributed product. So ODM is available on a range of platforms from cloud to distributed to Linux on Z to ZOS. But on ZOS, we didn't just want to port across the distributed product. We knew that ZOS is a unique environment. So we actually have a direct integration with CICS, batch, IMS, both online and batch work that allows a very high-speed integration of those rules with those applications. It's a cross-memory link within the LPAR, which gives very, very fast sub-millisecond response times to most decisions. And we wanted this to be an environment that could easily be integrated into existing configurations. So you don't have to resize your LPARS to put this in. So actually the rules themselves execute in Java. So the heavy lifting of the decisions actually happens in an offloadable Java environment. So once you get into that rule execution server, the actual rule execution is Java. And that's also what makes it very possible to share these rules across multiple platforms. Because whether you're running, say, your request for quotes in a cloud environment, or your quote renewal on ZOS batch, where you're taking your system of record and doing your overnight renewal to send out to the customers, you can be assured that you're going to get the same response for the same input data, because it really is the same engine that's running in both places. And from a COBOL programming point of view, it's very simple to use, because we just have 3 very simple COBOL-looking commands: connect to initially connect to a server, disconnect to disconnect to the end, and between those, as many times as you like, just call HBR rule in the middle that will actually execute the rules. And the code on the right-hand side here is, if you like, the minimum amount of code you need to actually connect to and make a call to ODM. So you can see it's fairly straightforward. Now, just very quickly to land here, to show that this really is workable in the real world. We had a large financial services company in the Northeast region of the US who had a large statement application that was written in ZOS batch. And previously, to make a change to that application took 9 months. They did an in-place modernization of that application. They actually rewrote it into Java to use in the batch container of WebSphere application server. But at the same time, they moved all the business logic that determined, what statements were required, how often they had to go out. And I didn't realize there was so much compliance required around those kind of things, so many rules that had to be followed. They moved all of that out into ODM. And the key takeaway here is their change cycle went from 9 months to 6 weeks. And of that 6 weeks, 4 weeks of that was actually in-place testing, because they were fairly conservative about what they wanted to do. They believed they could actually get that down to 4 weeks. So they actually saw a reduction of 7.5 months of IT resource effort. And apart from the reduction in cost of that, you're saving 7.5 months worth of IT resource. The key thing is they can then use that resource for something that's more revenue generating, rather than just maintaining a large application. So that's an ability to actually see that this can work in the real world. And actually, this is a project that went from implementation to production in, I believe, about 6 months. So again, it wasn't something that was, throw everything away and start again from scratch, and it's going to be 2 years before you see a result. You can start seeing return on your investment fairly straightforward and fairly quickly. So that is a very high-level introduction to what we mean by business rules and how business rules can handle things. I'd now like to pass over to my colleague Maggie, who's going to give us an introduction to machine learning and machine learning on ZOS, so that we've got a full background before we can compare and contrast between the two. Maggie.
Thanks, Chris. Hi, this is Maggie Lin from Watson Machine Learning for ZOS development team. So I'm going to give you an overview about Watson Machine Learning for ZOS, its architecture and what capability it offers, and then the integrated architecture with ODM, the Operational Decision Manager for ZOS. So what is machine learning? So unlike the traditional programming methodology, the data and the program are fed into the computer and for it to calculate and generate the output for you. Machine learning methodology is to feed the data and output together with the algorithm into the computer for it to process and then generate a program. In general, the machine learning process generates a program that is machine learning model. So machine learning models are used to make a prediction or classification. So based on the input data, which can be labels or not labeled. So for the model to providing you a prediction and an estimate about the pattern in the data. So why machine learning? It can take a lot of effort for the user to create the business rule, and the business rule need update regularly. But is machine learning always better than the rule-based approach? Of course, it's not necessary. So when do you use machine learning? So when you use machine learning, when the business logic is not known or not exact. So when you leverage the rule basis, you know the logic and you need the precision. So for example, if the condition A is true, then the action of B has to be taken. So the specific rule have to be followed. Then that's when you want to leverage the rule base. When leveraging the machine learning rule, that machine learning basis, when you want to make a prediction, but you don't have the exact rule to follow. And in the real world, it is very likely that you will take the hybrid approach to use machine learning together with rule base to determine the outcome. So what is IBM Watson Machine Learning for ZOS offer you? So many of our enterprise customers are telling us it's interesting to leverage the latest analytic technology like IBM Watson Machine Learning for ZOS. But however, they also want the flexibility to deploy on-prem. So when the majority of their data originate on Z system, they want to take advantage of the existing investment in people, in processes, and the infrastructure that on Z system, which can minimize the data movement and then the costly data movement and maintaining the high data governance and security. So IBM made it possible for a customer that you can use IBM Machine Learning for ZOS to satisfy this requirement, also to benefit of the latest machine learning technology on ZOS. So deploying IBM Watson Machine Learning for ZOS platform enable you to access the Z data in place and combining the data with other sources of information, such as structural or non-structured data from other systems. So you can build the model to predict the customer behavior to driving the business outcome. And by accessing the live data on Z system, you can be a lot more agile and then eliminate the ETL cost. So the highest security can maintain because you leave your data on Z without moving it around. So Watson Machine Learning for ZOS is the only AI platform that running on ZOS. So it providing you the low latency, then a high performance inferencing to supporting the scoring of every transaction without significant impact to your SLA. That's a service level agreement and the cost. So you can readily and cost effectively scale AI and take advantage of every inferencing opportunity to increasing your revenue or decreasing the cost to mitigate the fraud, for example, the fraud use case in the real time. So this allows you to infuse AI into the transactional application. So when the millisecond matters. So as you implement AI in your business logic, you need to consider where to build the machine learning model and where to deploy them. So Watson Machine Learning for ZOS gives you the flexibility that you can train or creating your model in any of the framework or any platform that you prefer. You can use your existing framework, or you can use IBM Cloud Pak for data to build, creating a model. And then deploy and operationalize this model onto Z to gain the unique advantage of inferencing on Z in real time in transaction. So this approach can offer you the significant value for the time-sensitive business areas such as fraud detection, loan approval, or the IT operational type of the use case or customer churn. So the best practice we want to recommend you is combining the machine learning approach with the rule-based approach. So the machine learning scoring engine integrate with ODM, the operational decision manager, to deliver the high-performance combination to ensure that the comprehensive AI-driven outcome with the data to make prediction and then for the best action and decision to take. So here is the full architecture of the Watson Machine Learning for ZOS. It contains the component running on the ZOS and also the component running on Linux. So the two lighter and blue box here are the Watson Machine Learning proprietary components and the bundle component. So all the component running on the ZOS, which is on the left-hand side, and can be standalone without the Linux piece. And the ZOS component by itself is providing the model management and deployment capability and with the scoring services. And it bundled the IBM Open Data Analytics, which providing the Spark and Python runtime, and with the Spark and Python library running natively on ZOS, and also providing the data access to accessing all the various data type on the ZOS, including all the structured or non-structured data, DB2 data, IMS data, and then the logs and the SMF data set. And then for the Jupyter kernel gateway, that's in the middle part of here, that is providing the access to the Spark and Python runtime on ZOS. And then the two light purple here is our prerequisite. Basically, our for DB2 for ZOS, that's where our metadata repository are stored. That's storing information about the Watson Machine Learning component and also storing the machine learning assets. SAF, that's the system authentication facility that's providing the authentication service for the product. So we support both RACF keyring store and the file-based key store. In the most recent release update, Watson Machine Learning for ZOS, we're also supporting and leverage ATTLS on ZOS for the secure communication. So for the right-hand side here, this is what we call the IDE, the Integrated Development Environment, where it's providing the model development tooling capability. So for our IDE, it's an optional component. If you already have your own existing framework to creating the model development, you can continue to use it and developing your model. So once the model is ready, you can deploy leveraging Watson Machine Learning on ZOS. So deploy onto Z, and if that's where you are consuming machine learning application run. So we're providing the data scientists the flexibility to the framework they are familiar with to do their work, and then operationalize and then deploy the model to Z if that's where the consuming application runs. Now, so what is the capability that offered by Watson Machine Learning for ZOS? So basically, we're supporting model inferencing natively to run on ZOS for the various model types, such as the popular Spark model and PMML model and Python scikit-learn model and Python XGBoost. And also recently, the new addition is the deep learning model, as long as the deep learning model can be saved in the ONNX format, such as TensorFlow, Keras, and the PyTorch. So those are all the various model type that we support can be run on the ZOS. And we're also supporting the end-to-end model lifecycle management. So the versioning support of the model that is supporting the multiple version of the model, that you can have a version that's readily running on production system, while the second version is being working on by the data scientists on testing on the test environment, so that we're supporting the versioning of the model on Z, and also supporting the easy model import, and then the model deployment process to the scoring engine on Z. And then also supporting the continuous model monitoring and evaluation. So for you to know that if the model continues to providing the expected accuracy for the prediction. And also the user access management. So that depending on the user role that are defined, that it has the user control to use the various different functions or the capability. And we actually also have the outer box, the solution template, such as the DB2 anomaly detection solution template, so that you can use this solution template to gain the outer box AI capability. And as I mentioned, that we also have this optional IDE that if you don't have an existing framework to developing the model, you can use our IDE environment to do the model development work. So now moving to the integration with ODM. So this is the architecture of Watson Machine Learning for ZOS scoring engine integration with ODM. So the best practice that we recommend you to combine the machine learning approach with the rule-based approach. Watson Machine Learning scoring engine can support also install into a library server that come with the ODM. So the operation ODM continue to enable the business rule, while Watson Machine Learning for ZO extend the rule-based decision with a machine learning model. And you handle the machine learning model management and deployment through Watson Machine Learning interface. And then the Watson Machine Learning scoring engine can install into the library server that come with ODM. The ODM managing the Watson machine scoring call under the cover through the Java interface. So it's transparent to the user, to your application. So you can continue to use your existing CICS and IMS or the ZOS batch application to call the ODM native API to get the decision through the ODM. Either it's the rule-based decision result or the ML-based decision result. So that's the combination, integration of these two technology together, providing you the decision outcome for the application. So now I'm turning back to Chris to talk about this, how these two working together.
Okay, thank you, Maggie. So we've been talking quite technical about the two different products and what they do. So let's just take a step back now and think about how we actually make decisions in the real world. So prior to this pandemic, I used to travel a fair amount, coming out to actually see you guys and work with you guys and help you get up and running. Hoping to do it again some point soon, but we'll see what happens. But often when I'm traveling, strangely enough, I find the need to eat. And one of the decisions I have to make is where I am going to eat. So the first thing I'm going to do is probably think about the different types of restaurants that are available, whether it's a fast food restaurant or a seafood restaurant or an Asian food restaurant or any number of different types of restaurants. And then I'm going to think about my past experiences. And I know in the past, I've not really enjoyed, say, eating seafood. So I'm probably not going to go for a seafood restaurant, but I do like spicy food. So maybe I'll think, actually, I might quite like a Thai restaurant. So I then will choose a Thai restaurant. Now, if I was to just say, well, okay, based on past experience, I would like a Thai restaurant and ask a system, give me the best Thai restaurant to go to, more than likely, it's going to give me a restaurant in somewhere like Bangkok, which if I'm visiting a customer in Minneapolis, isn't going to be much use to me. So I need to have some boundaries to go around that. So I need to be able to say, well, actually, what I want is a restaurant within, I don't know, 5 miles of my current location that isn't going to cost more than a certain amount, which is my daily allowance for meals. So in doing those steps, I will hopefully come to a decision about where I'm going to eat. And if we think about that now in a more technical term, we can think about the first step I made there was classifying the restaurants, into fast food, seafood, etc. And that's classic AI, classic machine learning capabilities to be able to look at that unstructured data, as Maggie said earlier, and not having a prescriptive way to go through things to actually be able to classify things together. I was then looking at my past experiences. What did I like in the past or dislike in the past? Again, that's absolutely the kind of things that we want to be looking at doing with something like machine learning, looking at our past interactions with our customers, trying to learn from them based on the past experience, trying to predict what might happen in the future, but then also bringing that ring fence around it to help get us to the final point of decision. And in my case, that was a certain distance from where I was and no more than a certain amount. So in that just very simple decision of where to eat, you could see that me personally would go through a number of steps that actually map onto the way we might want to automate a decision using something like machine learning and something like business rules together. So just another couple of slightly silly examples to help hammer that home. Now, I will start this with an apology. If you drive a yellow car, I am not picking on you. It is not personal. It's just I had to pick a color. So imagine, if you will, with me, that people who drive yellow cars are more likely to have accidents maybe than people who drive other color cars. Now, if I'm an insurance underwriter and I am writing the rules for pricing, then unless I have specifically gone to look for any correlation between the color of a car and the likelihood of someone having an accident and raising a claim against that car, there are not going to be any business rules that take that into account. One of the power of machine learning is the fact that, processing power allowing, I can throw as much data at it as I want. So if the data I give it associated with the claim has information about the car in question, and part of that information is the color of the car, if there is a correlation between yellow cars and the number of claims, you can absolutely guarantee that that is going to be there as part of your score when you run that as a scoring service. That will be built into the model because you have given it the data to start with. And of course, the machine learning algorithms can look through far, far more data than any single person or even team of people could hope to do themselves. So you can really create a much more agile decision by adding something like machine learning to that. Right, now let's turn it on its head. I'd like to introduce you to Sue. Sue is a 14-year-old and she would like a new mobile phone, or sorry, cell phone to be more global. And she goes to her bank and she asks the bank for a loan to buy her new phone of $1,000. And of course, if we were to just ask something that was looking at past history like machine learning, it might say, well, I have never seen an instance of a 14-year-old girl who's defaulted on a loan for a mobile phone. She must be the perfect person. Absolutely zero risk, lend her the money. Now, of course, in the real world, we're never going to do that because there would be those constraints we put around it. We wouldn't just say, just based on past experience, we have those compliance rules. So just in these simple examples, you can see how we're actually using the capabilities of both something like a predictive capability of machine learning and a prescriptive capability of something like business rules and ODM to help make even these simple decisions. So another way I quite like to think about this is to think about it in terms of, if you like, left brain and right brain. So our left brain tends to be the logical piece of our brain. It's the piece of our brain that thinks about things like writing, reading, calculations. The right side of our brain tends to be the intuitive side of our brain, the side that has imagination. And you can almost think about the compare and contrast of a business rule system like ODM and a predictive system like machine learning as being something like these two coming together. We need both sides of our brain to make decisions in the same way that I believe we need both sides of these two capabilities to make business decisions. So looking at what the various sort of, categories of things that they're good at, machine learning, obviously it's very good at perceiving. It's what it is designed to do. Based on past history, can you help me predict or perceive what future behavior is going to look like? If this class of people have defaulted on a loan before, can you predict whether this particular person is likely to default on a loan going forward? Obviously, it's learning, and that's key, and Maggie highlighted that. And that's not only learning in the beginning, but actually continually learning based on decisions that you are making day to day to show whether the decisions that are being made, the predictions that are being made, are still accurate. Now, we're not quite there at the abstracting level. The kind of deep learning we're getting with some of the Onyx models, we're starting to get into that area, but we're not quite there yet. And obviously machine learning, as Maggie said, the reasoning isn't there. We can't specifically say, this is why we came back with this result, because actually that's the power of it, is the ability to look for patterns. If we look at a rules-based system, it's, excuse me, there obviously is no learning involved at all. It can potentially be perceptive, but it's only ever going to be as perceptive as the person who is physically sitting there and writing the rules. If that person hasn't done the research and hasn't looked at that particular piece of information, there is not going to be anything in the rules to manage and handle that. Again, obviously no abstracting going on. It is just a series of statements that are applied to a piece of data to give a result. But obviously, you can very much get a reasoned answer for it because you can see the steps that were gone through based on this data coming in to have this result returned. And if we look at the kind of decisions that we're making, we can see some that kind of lend themselves more to business rules and lend themselves more to machine learning. But if we think about a lot of the actual business decisions we make, they can often contain several of these things. So you can imagine that you're looking for something like, I don't know, processing an insurance claim. One of the first things you're going to do is to check that the claimant is actually eligible to make a claim based on their coverage. But then you're going to look at whether there's a fraud element to this. You know, is this a valid claim based on maybe some past experience we've seen of people trying to get past us? You know, something like pricing is likely to be more on the prescriptive side. We want to price this, but it might be that based on past behavior, we want to apply a discount to this because we're worried if we price things at a certain level, a certain class of customer might actually leave us. So you can see that there's this kind of range of decisioning that we're making that kind of are always bouncing between the capabilities that we have of prescriptive business rules and predictive machine learning. And actually, if we put the two of these together, going back to my little table at the top, you can see that apart from the level of abstracting, which actually as a whole industry, we're just starting to get into, we get green across the board. By using the two together, we can actually get a perceptive, learning, reasoned decision, which we can replicate and replicate at speed. So what might this kind of actually look like? Well, you could imagine writing a piece of a business decision that says, if the client is at least 18 years old, so there is an absolute rule that's based on a business policy that we will not take an application if the client is younger than 18 years old, and his risk score is less than 20%. Now, that risk score could be coming dynamically from a scoring service based on the information we have about this customer right now with the latest model that has been trained against the past data for this scenario. So that's bringing that information right into the heart of this decision. And you might run this decision several times with the same input data. And based on the result that comes back from that scoring service, as it's updated, as it learns, you would get a different result. But then what we're applying to that is his risk score is less than 20%. And again, that might be a value that the business team need to set. Imagine we're doing, I don't know, credit card processing. There may be times of the year, say like, I don't know, around Black Friday, where actually we make a business decision to process more slightly risky transactions just because of the throughput that we've got than at other times of the year when we might say, well, actually, if it's over 80% likely to be fraud, then we'll absolutely block it. And at other times of the year, we might say, actually, even if it's over 70%, we want this to be looked at. Those kind of scenarios where a business sort of decision is applied on top of the result we're getting back from the score to actually make this then become part of the application. So you can see how we can actually combining the prescriptive nature and the predictive nature gives us a really dynamic, really good decision, or at least in this case, piece of a decision that we can make. So just another couple of examples, just to very quickly go through in different industries. You can imagine doing product recommendations where something like machine learning selects the products that a customer is most likely to want to be upsold to, if you like, based on what they're currently buying. And then we could use business rules to actually ensure we're offering something that they're eligible to and maybe pre-approve and price it. So they may come to us for a car loan. And actually, as a result of applying for a car loan, we could actually give them, say, and here is a quote for insurance for the car that you're already pre-approved for. And here's a good price with a discount based on what machine learning has said. I've talked about it a number of times, underwriting decisions. We could maybe use something like the likelihood of a customer to churn, to leave us, that actually would then feed into our pricing from business rules as to what we're going to charge them. Claims handling, how likely is it that this looks fraudulent? And that would be happen after we've done something like in the business rules, checking the customer is actually eligible to make this claim. And then if we do think there's something fraudulent going on, it might be something like the business rules that determines what level of oops, slides is jumping around. What level of where are we? What level of actual auditing needs to happen? Or we're automating loans. Again, probability of someone's defaulting the payment, and then we can use the rules to determine actually what price we're going to give them, that kind of thing. So I hope you can see within a lot of these examples, what we're looking at doing is to make a really good decision. We want to be able to bring these two capabilities together. We're using something like machine learning to take past data to actually create classification and scoring services, which we can then apply with the business rules that are applying the industry regulations, marketing pricing, subject matter expertise, those kind of prescriptive things together with the predictive things to allow us to have real decisions that much more closely relate to the way that maybe business decisions would have been made in the past when we actually came to physically see somebody in, say, seeing your bank manager to ask for a loan or your insurance rep to take out insurance. We can start making these decisions much more realistic and then hopefully much more powerful. So Maggie has touched on this a little already, but to say that the integration that we have actually is very high performance and very high speed. We can run both entry points to the products within the same Liberty environment on z/OS, where we have a very high speed Java in-memory call that happens between the two. Now, a key thing here is that, and I noticed we had a question about this earlier, so I'll answer it now, is that we have tooling for ODM that is focused on the business user and those business policy owners, and we have tooling for machine learning that is focused on the key data scientists and the people who can build those models. Now, those toolings are separate because the actors who need to use them are separate. I'll show you how the integration between them works in a moment, but obviously we want to have the business focused tooling for the business people for what they need to put in place, and the tooling for machine learning focused on the actors who are best placed to create the models, the data scientists, etc. Where the key integration happens is at runtime. And another question we had is, does this perform? Yes, very much so. We recently did a POC at a large bank in Canada, and we were seeing transactions go from an IMS batch application across into the Liberty environment, running some rules, running a predictive scoring algorithm, coming back into the rules and returning an answer to the IMS application in the region of 2 to 3 milliseconds. So something that was very easy to be consumed by that application. And as for the actual integration itself, if you want to actually use a scoring service within a business decision within the rules, the way to make the rules call out to that is there's tooling built in on the ODM side that can actually go off to Watson Studio and ask for what predictive scoring algorithms are available, what scoring services can I call. It will pull down the interface definition for those and then actually bring into the ODM side a data model that represents that. So we can start making those decisions that look very much like we were looking at earlier here, where this data for high risk score and what needs to be passed to the scoring algorithm to return that high risk score is actually available as language that I can just use within my rules. So I can literally write something after I've done this integration that looks exactly like that decision there. I would allow you to bring the two together very easily. So that's been a very high level look at the two products, a high level look at why you might want to bring the two of those together. And we've got a little bit of time now for questions for those who are online. There's a Q&A at the bottom. I think we've covered most of the ones that were there. If there was any more, there's a moment now for you to type. But I realize that very often with these sessions, particularly when we have such a short space of time, we tend to raise more questions than we give you answers. So I would like to land on this slide, which is where you can learn more. So for both ODM and Watson Machine Learning, I'd very much recommend you go off and look at our main websites, of which the URL is there. there'll be more information there. But if you're like me and you really only learn about a product by getting your hands on it and actually trying it, I would really like to recommend these trials that we have available. For ODM, we have a link here to our Z trial. And if you've not seen the Z trials, they're great. It's an ability where basically you can get access to an environment to actually work through some simple examples, a bit like you would do a workshop at a conference or something like that. And then we allow you to actually work through an environment. You have it for 3 days, and at the end of the 3 days, it goes away. There's no commitments, there's no nothing. And if you want more time, you can just request another one for 3 days. And on the Watson Machine Learning side, they actually have a much longer trial. They have the ability to actually have a 3-month trial, and there's a link there to how you can get that, where you can get hold of an environment where you can actually physically get hands-on with it. And I would really like to push as well that if you've not signed up for it, because it's coming up very soon, it's next week. If you've not signed up for the IBM Z Day virtual conference, I would really recommend you do that. I've seen the schedule for it. It looks great. It looks really exciting. I would really recommend that you get yourself on that and get the information from there. So I hope that's been useful. I thank Maggie for joining me in this session. Our emails will be available. If you want to contact us, please do. I believe that this recording and these slides will be available to you. You should get a follow-up email. So if you have any questions, please let us know. I hope that was useful, and thank you for joining us today for this webcast.